Tetrahedral geometry is important in organic chemistry because it describes how atoms arrange around a central carbon with 4 single bonds, which determines molecular shape, physical properties, and how molecules react. Think of a carbon atom like the center of a 4-armed windmill, where each arm pushes away the others so they spread out evenly. That shape is called tetrahedral and keeps the bonds as far apart as possible. Because the arms point toward the corners of an imaginary triangular pyramid, the molecule has a specific 3-dimensional shape that affects how it fits with other molecules, how light passes through it, and how stable it is. This shape matters when molecules bump into each other during reactions, because the positions of the bonds decide which parts can approach and react. When one of the bonds is to a different group, the tetrahedral arrangement can make 2 versions of the molecule that are mirror images, and those mirror images can behave very differently in the body or in a chemical test. A common mistake is thinking that drawings on paper show the real shape, when flat pictures can hide the 3-dimensional tetrahedral angles. So holding a model or imagining depth helps use models or simple 3-dimensional sketches to fix that. Another error is assuming all carbons are tetrahedral, but carbons with double bonds or rings often have different shapes, so check the bonding before you decide the geometry. Students also sometimes believe tetrahedral always means identical behavior, yet different groups on the 4 corners change reactivity and properties. So name and compare the groups to see how the molecule will act. For more videos and clear resources about how tetrahedral geometry affects molecular shape and reactions, visit www.gumballdegree.com.